Hi, welcome to Train Signal. We're continuing our Windows Server 2012 Advanced Features course with an exploration of ADFS, Active Directory Federation Services. ADFS is something you deploy when you and a partner organization or you and some other part of your corporate organization want to be able to share data. You want to be able to make available web-based applications and things of that sort in your organization. But you run into the interesting challenge that perhaps you don't share an Active Directory organization because you're two separate private organizations. You don't want to build an AD interaction. Or indeed, you're not even running Windows in one of those two organizations at all, but you still want to be able to share information that'll allow for authentication into each other's resources. Well, how do we manage that? ADFS is the overall solution, an important part of which is the configuration of claims providers and relying parties. So before we jump into formal discussion of claims providers and relying parties and things of that sort, by way of quick review, it's worth pointing out that ADFS's primary job is to implement a claims-based authentication scheme. And claims-based authentication is a way to be able to pass data that is authenticating, it's information about somebody's identity, but again in a way that doesn't require a shared Active Directory configuration environment. In our example here, we've built a relationship with a partner company. We've taken on a new investor, the Cash Cow Capital Group, and CCCG wants to be able to get at a web application of ours here at GlobalMantics. How do we make it happen? They've got a totally different AD environment from us. We don't want to blend the two, but we want to give them access to our web application. Well, what I don't want to do is to have to create manually user accounts in my Active Directory environment that gives access to their employees and then have to maintain passwords and email them to let them know that the password on my side of the environment changed. Of course, that'll be different from the password that they're using in their AD environment. Yuck, I don't want to be any part of that. What I want to do is somehow allow the ability for users in their Active Directory environment, using their ADDS domain controllers, to be able to pass information about themselves in a way that my ADFS environment will recognize. And ADFS has exactly that goal, to transform credentials about a user into something that I can pass across any network connection without any presumptions about what's on the other side of that connection. That means that on the Cash Cow Capital Group side of the house, users are going to call their ADFS server and say, hey, I'm trying to talk to that ADFS environment over there. Can you help me prove my identity? The starting point actually happens when the client goes and calls the web server on the other side. The web server checks that incoming client request to see if it has a cookie that proves that it's a valid user. It doesn't. That web server refers the client back to their own ADFS server. So the client calls the ADFS server, says, hi, I'm a user. I just got logged in with Active Directory. I'm this user. I've got this title. I got this department. I got this division. I've got these other credentials about me in Active Directory. Can you build a description of that we can pass across this network connection between us and this company called GlobalMantics, who we just invested in? And ADFS does just that. It builds a set of claims, a set of statements about a user based upon Active Directory data, and that data is packaged in a way that lets us send that request over to the other side of the network. So that instead of being told, no, who are you, I'm not letting you in, that other server can receive that package of data, compare it against some access rules that determine under what circumstances I let somebody into my organization, and a user in the partner organization in the Cash Cow Capital Group network is able to access resources in the globalmantics.local network. Here's what things look like on the relying party side of the house. The relying party is the organization that's trusting the incoming claims information from that other Active Directory organization over there. The local ADFS server is able to receive the claim information coming from the partner's ADFS server, which checks it against a set of rules to see if we allow people named Bob who are managers in the marketing department in a certain division, things of that sort. I'll check a variety of rules to govern whether somebody is allowed to get in or not. If they are, my ADFS server will give that user a stamp of approval. So at the end of this process, the ADFS server has received claims from Cash Cow's ADFS server. It's taken that data and built a new access token of a sort for that user and passed that back to the client. The client now brings that with it when it goes to visit the web server and says, hey, can I come in? And because that client is now presenting credentials that the local ADFS server says are trustworthy, the web server says, hey, If the ADFS server says he's a trustworthy person, good by me. I'll trust that that identity is a valid one, and I'll use that to determine what this user can and cannot do in this web application. So that's giving me the ability to extend the idea of authentication to identify who is allowed and who's not allowed to perform tasks in my system across a network boundary that doesn't necessarily include an Active Directory environment, and indeed across whole operating system platforms. Again, Unix versus Windows can work cooperatively using this sort of an environment. Now for that to work, we need to get ADFS properly configured. We installed it in a different lesson. If you were there for the installation process, you know how to turn on the basic service and be able to get it installed on a computer. But getting it configured is a couple of additional steps that we haven't gone through as of yet. So let's take a moment to look at what that looks like from GlobalMantic's perspective. So here I am on GlobalMantic's ADFS Server 1. My little notification area tells me that I did successfully install ADFS, but I haven't yet run the configuration wizard that lives in the ADFS Management Snap-in. So I'll go ahead and click that link. That's going to launch my ADFS MMC GUI, in which I'm going to click the link to launch the ADFS Federation Server Configuration Wizard. We've got two main options here. One is to launch a new ADFS server that is operating kind of as a standalone server. We're building a new ADFS environment for the first time, and we're rolling out our first lowly server. Alternatively, we might be in the process of building a server farm, a collection of ADFS servers in a network load balancing cluster to be able to field a large quantity of traffic coming across the network from our partner organization. In this case, they're a small organization. They're a staff of a half a dozen people. They've got deep pockets, but they've got a lean staff, so I'm not expecting lots of incoming requests. So we'll assume that a single ADFS server will be adequate here. So I will start by creating a new standalone Federation server. It's all by its lonesome. I'll choose standalone here to say this will be my first and last server for this environment. I'd have to start all over if I decided later that I wanted to add other servers. Alternatively, I could say I want to build a new Federation server farm, and I'll need multiple Federation servers over a period of time. In this case, for simplicity's sake, and because this is a small network environment, I'm going to use the standalone scenario. Next important question is, which SSL certificate am I going to use to get my work done? We're passing secure data about authentication details across quite probably the internet. Not always the case, but in a number of cases. You may recall that I called the guys who run the Cisco routers down the hall, and they set up a VPN between the routers, so I don't need to worry too much about secure transmission of that data, but nonetheless, ADFS is going to rely upon SSL, Secure Sockets Layer, to encrypt communication with the ADFS server. ADFS, you may recall, gets its job done using web services. It's exposing functionality by way of IIS, the web server. And the right way to secure communication traveling to a web server, to and from a web server, is with SSL. Same technology you use to be able to secure your communication with an e-commerce site that you purchase things from, or the bank where you transfer balances and things of that sort. And you'll note that at the moment, there's no certificate that the system recognizes as a valid SSL certificate for this purpose. So let me bail out of my wizard here. We'll come back to that in just a moment. Let me go launch the certificate snap-in. I'm going to launch the MMC, Microsoft Management Console. Into it, I'm going to go add the certificates snap-in. As I do, I want to use it to manage certificates for the computer account for this computer. Looks good. Click OK. There we are. As I open this up, I see the list of logical certificate containers, the collections for different kinds of certificate uses. Ultimately, we're looking to deploy a personal certificate, one that's specific to this computer and describes itself in some fashion. But specifically, I want to make sure that we're deploying our certificate in such a way that it's treated as a server authentication certificate, one that's able to allow this server to prove its identity to some client that wants to connect to it. I want to supply the public key of this certificate to clients so that they can send messages that only this server can unencrypt. I want to send secure transmissions to this server. We're resting on PKI again, public key infrastructure. Encrypt with the public key, decrypt with the private key. So how do I make it perfectly clear that what I'm creating is a certificate that's going to be used for server authentication purposes? So what I like to do is this. I'm going to go right click my personal container here and change the view from logical certificate stores to certificate purpose, in which case our view of those certificate containers changes to show the set of certificates that fall into one of a long list of different kinds of certificates that I might potentially use. The one that's relevant for us here is server authentication. I want a certificate that allows this server to prove its identity to somebody else. So I'm going to go right-click that container and request a new certificate. Now I've already called the CA manager to ask her to set up the web server certificate. The web server certificate, so-called, essentially deploys the server authentication template. So we need to make sure that the web server template has been configured so that this computer can enroll for it. Remember, that's going to be done by configuring permissions. If I'm going over your head here, go back and revisit our lesson on certificate deployment and management of certificate authorities. That'll fill in some gaps for you there. So we can see here that the CA administrator deployed the web server template. So I'll check that. It needs more information about me to be able to enroll me for this certificate, so I'll go ahead and click that link. And it wants some information to identify me, the consumer of this particular certificate, which is to say this computer. Well, how am I going to describe myself as a computer? Our main orthodox way of doing that is the common name. Common name, for practical purposes, is the DNS resolvable name of this computer, which in this case is globomantics adfs1.globomantics.local. I could alternatively supply something called a subject alternative name, some other piece of data to help identify that object as well. In this case, it's not strictly speaking necessary. I like to supply the DNS information, which is essentially going to be the same piece of data, but we're making it clear that this is a DNS resolvable name. That done, I'm going to click OK, click Enroll, and this computer has been enrolled for a certificate, which is to say, I've got it. If I look at the list of server authentication certs, I can see a certificate called GLB ADFS1, issued to me from the CA running at Hyper-V Host 1. It's a CA that I deployed on the actual Hyper-V host computer that's providing access to this virtual machine. I'm going to go look at the details of that certificate by right-clicking it and choosing to open it. I can see that this certificate does deploy the certificate template called web server. It exposes the server authentication usage. It uses a subject name of globomantics adfs1.globomantics.local. Is that a valid certificate? It says it's okay. That certificate got its information from the globomantics CA. That CA is a trusted CA. We're in good shape. So that means when I go back to my ADFS configuration wizard, we won't trip over the need for a certificate because there is now an SSL certificate on this server. We're going to imagine that on the other side of the network, our counterparts at Cash Cow Capital Group are setting up the exact same type of a configuration. And this time we can see that we do have an SSL certificate at our disposal. We are intending to expose it by way of port 443. I can go view that cert, and everything looks fine. All that done, I'm going to click Next. It's telling me what's going to happen next. It's going to stop the ADFS server service. It's going to build an instance of Windows Internal Database. Again, that's effectively SQL Server Express Edition. It's going to generate internally certificates for token encryption and signing. One of the key goals of the use of our ADFS server is to validate the data being passed from one ADFS server to the other. The use of certificates is an important part of that. Some of them are used internally. Others, the communication is going to rest again upon that SSL certificate that we just set up. The others are usually internally generated certs, and that usually works just fine for most purposes. Next, it's going to take my SSL certificate and apply it to our IIS environment. Remember that the ADFS functionality is exposed by way of a web service. It's an application running at the IIS server. The SSL cert is going to encrypt and secure the communication to that web application. We're then going to give a user account access to the ADFS database to get that set up properly. We'll configure a set of what are called endpoints. I'll define that idea in a bit. Let's hold off on that thought for just the moment. We'll post a website at our local IIS server /ADFS/LS. This is going to be our connection point into authenticating into ADFS. It identifies the name of my Federation Services environment, and we prepare to start the ADFS server. Let me go ahead and click Next, and off it goes. And that's going to take a moment. Let me go ahead and warm up my flux capacitor here and jump about 3 minutes into the future to a point where this is finished installing. Ready? And there we go. We finished the configuration wizard. I click Close here. And the ADFS GUI updates, retrieves data from the Windows Internal Database. And I can see that ADFS now provides me with a couple of configurable nodes identifying the relationship between the claims provider and the relying party. If this computer is to be one that's going to communicate with a relying party over there, where that other organization is going to be relying upon information that I send, I configure a relying party trust on my end to figure out how to supply data that will make the relying party happy. By contrast, if the other organization over there, as in this situation, is the party trying to connect into my environment, where they will be supplying claims to me, I will configure a claims provider trust on my end of the connection to describe the incoming claims. It's a little bit backward sounding. Common sense would say that the claims provider configures the claims provider trust, and the relying party configures the relying party trusts. It's quite the opposite. The claims provider configures a relying party trust to describe what to send to the relying party. The relying party configures a claims provider trust to describe what's coming in from the claims provider. I'll break that idea down in some more detail in a different lesson, but for the time being, I do also want to draw your attention to the information about the certificates. We can see that this ADFS server is characterized by an SSL certificate, common name equals GlobalMantics ADFS1, that should look familiar, and 2 self-signed certificates. The ADFS server itself has generated those 2 certificates, one to do encryption of data, one to do digital signing of data. But a very important part of the magic of the way ADFS works is described in this interesting container here, somewhat subtly named endpoints. What are endpoints? Endpoints are the connective tissue between ADFS servers. An ADFS server that wants to work with another ADFS server has only the ability to talk to the web services exposed to that other end of the connection. So what we're looking at here is the list of the various pieces of my ADFS server, which URL they're located at. These are all relative to the local server, of course. We can see that these objects are implementing various pieces of the WS-something specifications for building claims-based authentication across a neutral network of some sort. I also want to draw your attention to the bottom of the list, a file here called Federation Metadata. This is going to become important in a different lesson as we start to build the claims provider trust, the relying party trusts. For our 2 ADFS servers to be able to talk to each other, they need to understand each other's configuration in rather a great deal of specificity. How do we make that happen? One way to do it is to exchange this file, this XML file. But I will save that for another lesson. For the time being, we've accomplished the job of preparing an ADFS server that can either be a claims provider to be able to supply data about local users to a remote network within which there's an application that my local users want to connect to, or to set the server up as a relying party, in which some remote organization is going to have its users connect to my web application, and my ADFS server is going to catch those incoming claims and validate them against the rules that allow me to determine whether or not I'll let somebody connect into my environment. But for the time being, that brings this logical lesson to a close. I look forward to sharing more ADFS configuration with you in our other lessons.